In this video, I'd like to make a quick digression into inheritance in Substance Designer. What is it? How does it work? And why do you need to understand it to make the most of your graph? Now you remember that each node comes with base parameters, and these parameters are present in all the nodes. See, if I click on any of these nodes, they remain the same. We have things like the size, the bit depth, the tiling, etc. They can be changed locally, but before doing so, it's important to understand the logic behind it. Next to each of these parameters, there is a little icon that indicates the method of inheritance. It basically says from which source the parameter gets its value. If we click on the icon, you see that there are three methods of inheritance: relative to input, relative to parent, and absolute. Now please bear with me here, it's not that hard and it's important that you feel comfortable with these notions. So, relative to input means that the node takes its parameters from its primary input, what is piped into it, if you will. You can spot the primary input by these dark dots in the middle. So this one takes after this one, which takes after this one, and so on. And this is how it goes for most nodes. Now please note that it's important to keep track of the primary input, especially when it comes to blending. The primary input in a blend is always the background. I have two nodes here that I wish to blend: a gradient that has a 512 resolution and a purlin that has a 2048 resolution. If I blend the two by putting the gradient on the top here, my blend will inherit its parameters from the purlin, and these parameters will then be passed over to the next node, and so on and so forth. But if I swap the inputs, and by the way, there's a neat shortcut for that, you just press X, so X to invert the connections. Well, if I do that, my gradient is now the primary input, and so the blend takes on that new 512 resolution, which can cause issues down the way. This is especially true when it comes to bit depth variations. For example, if you blend an 8-bits image with a 16-bits image. Now, we won't dive into the bit depth topic, but let me show you a quick example. I have this very basic setup here, and you see that I'm blending an imported bitmap that happens to be 8 bits. If I plug it into the primary input of my blend, this bit depth now propagates to the whole setup, and it results in these normal artifacts that you see here, because 8 bits often struggle with smooth transitions. So if you ever end up with bending or stepping issues, it's very likely that you have an 8-bits node somewhere in your graph that messes with the final result. There are two ways you can fix it. The first solution would be to simply demote that image to the foreground input so that the blend picks its bit depth from here. But if your blend is not commutative, meaning if your inputs have to follow a certain order, then you will have to change the bit depth of the culprit manually, and I will show you how in a second. Okay, then we have relative to parent. The parent here is the graph itself, so if a node has its base parameters relative to parent, it means that it's taking them after the graph parameters, which we had set, remember, when we created the project. Now, I just said that most nodes were set to relative to input, but when there's no input, for example, here we have a uniform color where information only goes out and nothing comes in, well, in this case, the node gets its base parameters from the graph. And finally, we have absolute. This one is very straightforward. It lets you override any inheritance and change the parameter yourself for a specific node. People are often confused as to why these parameters are grayed out, but it actually makes sense. They are deactivated as long as they get their value from an external source. If you want to take over this, you just need to switch to absolute, so block the inheritance, and set the parameter yourself. And this is what we're going to do for this node here to fix our bending issue. Just toggle the bit depth to absolute, then manually set it to 16 bits. And now our artifacts are gone. Let me illustrate quickly what we just saw by getting back to our graph and going to the very first node, which is this fibers 1 here. And just by looking at it, I know that it must inherit its base parameters from the graph because it has no input, so it cannot be relative to input. And if I check the icon here, it's indeed set to relative to parent. Now I'm going to switch this to absolute to set a lower resolution and see what happens downstream. And just as expected, the other nodes now take on that new resolution because they inherited from this guy here. But for some reason, our tile generator has kept its original 2048 resolution. Can you guess why? Yes, well spotted. The primary input here is empty, and so the node just falls back to the graph resolution, which in this case is still 2048 by 2048. I hope it all makes more sense to you now. If you'd like to know more about inheritance or have other practical examples or use cases, I invite you to check out the documentation page on that topic. It's really clear and helpful, so go check the link in the description. And with that said, let's get back to our main graph.